Okay. Good day from here. Thank you and welcome to my channel. Today we are looking at another number theory question from Nigerian Math Olympiad junior category. We are solving series of problems from the number theory section. The last video was on the first question. Today we're looking at the second question. The question says, find the smallest positive integer which consists only of zeros and ones when written in base 10 and which is divisible by 12. See how I approach this problem. Has to do with number theory. Also to pick important things they told us here. They say this number has to be divisible by 12. The number has to be divisible by 12. And the number will consist of nothing but zeros and 1. No other digit is allowed. You just need to have zeros and 1 in the number. So all the options are made up of zeros and 1. We don't have to bother anymore. So we'll quickly go to this. How do we know a number is divisible by 12? Based on the divisibility rule for 12, usually most of you stop at 11 in the general class, but in competition class, you have to learn the divisibility rule for numbers bigger than 11. So 12, for example, how will I tell that a number is divisible by 12? Based on elementary concepts in number theory, a number is divisible by 12 if the number is divisible by 3 and 4. 3 and 4. Yes, we know that 3 and 4 will multiply to give us 12, or both of them are factors of 12. I can call them factor pairs in that they multiply to give us 12. But it's not true for every factor pair. We cannot say that for 12, if the number is divisible by both 2 and 6, well, because 2 and 6 are not relatively prime, but we use 4 and 3 because the numbers are relatively prime. A kind of digression here. If we're talking about 24, for example, how will you tell that a number is divisible by 24? Obviously, you will not use 4 and 6. So if the number is divisible by both 4 and 6, therefore is divisible by 24, that would be a big lie. Rather, we'll use 8 and 3. 8 and 3. So if a number is divisible by 8 and also divisible by 3, that number must be divisible by 24. That's elementary things we need to solve this problem. So we've been able to ascertain that the number must be divisible by both 3 and 4 before it can be divisible by 8. No, sorry, 12, as our question says. So now, how do you say a number is divisible by 3? For a number to be divisible by 3, that means the sum of its digit must be divisible by 3. The sum of its digit must be divisible by 3. So we look at all the options. The sum of their digits is divisible by 3. The sum of the digits is 3 here. So this number is divisible by 3. The sum of the digits is also 3 here. This is divisible by 3. The sum of this is also 3 here. The same thing for all of them. So all of them are divisible by 3. They pass the first test. Now let's come for 4. With how many of them is divisible by 4? That will be the answer. Which of the number is divisible by 4? For a number to be divisible by 4, by divisibility by 4, it must be that the last 2 digits of that number is divisible by 4. The last 2 digits. So when we look at option A, the last 2 digits, which is 0, 1, is not divisible by 4. So option A is eliminated. We cancel option A. Option A is not the answer. We look at option B, the same thing. The last 2 digits is 0, 1, not divisible by 4. Then option C, the last 2 digits is 0, 0. So 0, 0 is divisible by 4. That is the only correct answer. We can check the other options to eliminate them. So option C is the correct answer to this question. Option D, 10 is not divisible by 4. We cannot divide 10 by 4 without remainder. Therefore, that's not the correct answer. We look at the next option. That's option E. 11 is also not divisible by 4. So we'll conclude that these ones are not correct. The correct answer is option C. Option C is the correct answer. Thank you.